Why, hello there, ladies and gentlemen. How you guys doing? All right, so this has become a norm for us in class. I think, thinking about the day, we took pretty much all day to copy notes. Like that doesn't seem like a very efficient use of our time. So I'm going to start asking you to take these notes outside of class. I certainly can still be taking notes while the class is going on, but those are probably the quick kind of processing, kind of just in your head, trying to keep those ideas alive kind of notes. And these are going to be the more formal. We're going to take our time, really kind of do the slowly kind of notes. So again, there's a good and a bad way to do notes. And we should probably kind of just take a second to talk about that. And the bad way to take these notes are simply just to copy down what I'm copying down without engaging in the thinking process with me. The thinking process takes time, which is why to take these notes takes time. So make sure you are thinking with me in this process, and I really appreciate it. If you exercise good note taking techniques, especially in conjunction with a video, which might be new for some of you guys, which is don't be afraid to pause the video, think ahead, put down what you think is going to go on, and then play the response afterwards. The worst way you can probably take these notes and get the least amount from it is to simply just watch this video and then copy down everything I have verbatim while you're listening to music. Like that's not going to be the best way to do this at all. Um, and I'm going to ask you to do something at the end of these notes that I think is really going to help you continue the process of this. But anyway, I've talked long enough. Let's get to it. Go ahead and let's fill out kind of the incidental parts. So we know my name's Collins. These are my notes. How you guys doing? Uh, Class period all because this will be for all the classes, and this will probably take place for most people on 10, 11. But of course, and if you're wrapping around to Monday, let's see, that'd be 12, 13. So it'll be 14. If you're talking about topic or objectives, well, this is really definitely talking about rotations. Okay? Rotations, of course, being what we talked about the last few days, and we finished, hopefully, today. So let's keep going. Essential question. Well, the essential question is what these notes are going to be all about. In the end, these notes have got to be about how do you prove something's been rotated. Not just casually say, not just indicate, not just try to have a conversation about, but actually prove. So I'm going to go ahead and record that in my essential question box. Okay, so my essential question is how can prove an image by a rotation. Okay. Okay, so these are becoming pretty common for us, so you probably know what I'm going to do first. Um, the big question, the first question, is what are the essential vocabulary terms? What are the important vocabulary terms for rotation? Okay. Without further ado, let's tear into the vocabulary, shall we? So first and foremost, in fact, there might not be actually too many. The big idea, I think, is going to be what is a point of rotation? Okay, so lots of things about point of rotation that we need to kind of cover. I'm going to do a little sketch here. You guys can do one too if you'd like. I'm going to actually do it just below the point of rotation so I can kind of talk. And again, part of this process is kind of thinking about the notes while we're processing the notes. It's going to help our long-term memory storage. So I have this point A, and I want to rotate, say, to point A prime. The point of rotation is at that center, or in other words, this is of course center rotation. I'm going to be abbreviating C of R, center of rotation. Um, so the center of rotation is a point that serves as a pivot. So a good way to think of the center of rotation is as a pivot point. It's also going to be the point that's equidistant from both the image and the pre-image, and it's also going to be the point that serves as a vertice of that angle of rotation, and also additionally serve as the center of the circle that dictates where those points are actually going. So the center of rotation is going to serve lots of different purposes for us. It's going to be, what color do you guys say? Light blue. Okay, it's going to serve as a pivot point of the rotation. It's going to serve as the point, or the vertice of the angle. And it's also going to be the center of the circle. Of course, and when we're saying circle, we're saying the circle that dictates the distance from A to A prime. And so we have so much going on here that we're going to call the point of rotation. But again, it's going to be the big point here in the middle. And one way that people have been distinguishing this point of rotation is the only point on the plane where during a rotation that doesn't move. So I'm going to kind of record that here. So it's the only point on the plane that doesn't move during rotation. Okay, so what I mean is this, and this is a feature notability that you guys can play with too. If I'm going to be rotating this contraption right here from A to A prime, if I'm picking a center of rotation and I'm twisting this, the center of rotation is the only point that does not move. All other points move. All the points along the line, A and A prime move. The only thing that does not move is that center of rotation. And a good visual for this will be kind of like a clock. And I know I was moving around a bit, and I apologize. Notability is not great, not perfect for this. But a good kind of visual for this would be like a clock. Like if you can picture a clock in your head, or I'll try to draw a very crude clock right now. Okay, so you got your clock, you got your center, you got your like minute hand, you got your hour hand. So the hands move about the center. They're rotating. The center is actually the one staying put. So something to consider kind of moving forward is that the point of rotation is stagnant, is staying still. Let's move on to the next piece, and that's going to be angle of rotation. So if the point of rotation is going to serve as the center of the angle of rotation, it behooves us to know what in the world the angle of rotation is. But this is pretty straightforward. So if you think about, again, I have point A, and I'm trying to rotate to, say, point A prime. And let's say my center of rotation is right here. The angle of rotation is going to be the angle defined between the pre-image, the center of rotation, and the image. That is the angle of rotation. So we can put that into some phrasing here. It's going to be the angle formed between the image, a pre-image, the center, and the image. Okay. Another way to think of this angle of rotation is it's going to be the precise angle which you're rotating. Whoa, there's no E on which. That's just bananas. The precise angle at which the pre-image is rotating. Okay, so if I say the angle of rotation is 40 degrees, what that means is that that angle right there is now 40 degrees. If I say we're rotating point A 30 degrees around the center of rotation R, that means that guy right there is now 30 degrees. So we have the point of rotation, we have the angle of rotation. Let's see, are there any other important terms we have to know? I think we're good right now. So let's talk about, let's actually wait, let's draw a break. I always like to break my notes. Bam! Okay, let's go ahead and talk about now how you can actually tell something is a rotation by construction. So we're going to record that. Let's see. How can you tell a point has been rotated I'm sorry. Has been mapped by a rotation. Okay, and very specifically, I think there are two definite ways you can tell. There's certainly the verbal, of course. You can have the sketch indicating what you want to do. I think the first way you should be able to tell something's been mapped by rotation is by the rules. So when I say the rules, it actually comes in two different forms. Um, we have the actual coordinate rules, and those are broken down in various steps. I know we didn't talk about much in class because, as you guys know, they're extremely limited, but it's still information that you might be responsible for knowing, so I'm going to go and lay it down here. So if we have a 90-degree rotation clockwise, and we're going to say about the origin, okay? So we have a 90-degree rotation about the origin. The rule, as stated, is the point xy travels to y comma negative x. If you have a 90-degree rotation counterclockwise, again about the origin, you're going to have xy is going to end up at negative y comma x. Now you might want to go back and review that on the investigation because I know some people got tricked because there was a zero involved. Not a big deal. That's one of many aspects that we're kind of exploring. And then finally, we need a 180-degree rotation. And again, we're going to go about the origin. And now that's simply going to be xy going to, what is it, negative x, negative y. Okay. Now, those rules are important to know, but it should be noted that these are not the most important rule to know, simply because that there are limitations to this. So if you're on the grid and you're using these rules, that's great. But if you're on the grid and all of a sudden you're off the origin, because if you notice, all these points were centered about the origin as a point of rotation, then these rules become less useful. Now, when we talk about translations coming in next week, that's going to change for us a bit because there's some combinations we can make. But at this point, right now, those are rules that I want you to be aware of, but I also want you to acknowledge in the same breath they're really not all that important to memorize. Just maybe have them on hand is a way you can actually prove these things are working. Now, you may be asking yourself, Mr. Collins, you didn't give us all the rules. You gave us like one for a 90 right, one for a 90 left, and one for 180. But you should kind of consider some statements in which I can make these statements to the right. That's all you probably need, at least for the big ones. Because if you consider that a 90-degree rotation, say, clockwise, is the same as a 270-degree rotation counterclockwise. Now, before you freak out, before you're like, well, that doesn't really compute very well, consider this. Actually, let's go highlighter. I'm fun with that guy. If I take this point and I want to rotate it, whoa, Mr. Collins, that's crazy. Okay, if I take this point right here and I want to rotate it 90 degrees clockwise, it's the same exact thing as taking that same point and rotating it 3 quadrants the other way. So a 90-degree rotation clockwise disallows or precludes me from actually trying to say identify the 270 because they're the same exact rule. For that reason, or for that kind of same reasoning, if I map a 90-degree counterclockwise rotation as the same thing as mapping a 270-degree clockwise rotation, and then, of course, a 180-degree rotation one way is the same as a 180-degree rotation the other way. So I only have to name one of them. So those rules are for what they are. They're just limited. And if you notice, we're always taking chunks of 90. There are rules that exist for other angles but 90, but we're not exploring those because, man, they just get bananas. Now, the rules actually have a second part of that, and that's going to be the more general rule. Now, this is no surprise. We had a general rule that existed for reflections, so we're going to have one here that's going to exist for rotations as well. So the common terminology or common abbreviation is going to be a big R. Now, the sub on the big R, in other words, the writing that goes just below it, it has to identify two things. And again, not a surprise, because you have to identify two things to really identify rotation well. You have to identify the angle of rotation, and you have to identify the point of rotation. So I'm going to try to indicate that the best I can. Let me switch up colors here. So you have to identify the angle of rotation and then the center of rotation. You have to give this thing an argument. Another way to say it is you have to give it a target. So this is going to be of the pre-image. Okay. And that is going to end up going to the image. So like for example, and I'll go ahead and put an example here. Let's say I have, and I'll use a non-grid example for this. Let's say I want to rotate A about the center of rotation C to go to A prime. That would force the rule to be the rotation. Oh, we should probably identify an angle as well. So I'm going to say angle x. So I want the rotation of x degrees about the center C of A, and that thing is going to end up at A prime. Okay, so the notation stuff for us is going to be new, but it's something we're going to be using all year, so just get used to kind of seeing some wacky notation, all right? So that's the rule. We got the general rule. We'll explore that more. So if that doesn't make a ton of sense right now, trust me, it will by the end. It's a process. You got to keep buying into the process. We're going to skip the summary here because we got some notes to continue, actually. Remember, the question still is, how can you tell a point has been mapped by a rotation? So we talked about the rule. We talked about the general rule. So what has to come next has to be the construction. So let me go ahead and make a little subtitle here. So this is a construction. So in other words, what do you actually have to show? So the burden we have to show is actually twofold. So you must show, one, that the distance from the center point of rotation out to the image and pre-image are the same. Okay, so the distance from the center of rotation to image and pre-image are the same. Okay, so what's a typical way to show that? Well, the typical way to show that, and I think I'm going to try to maybe diagram this guy just over to the left here, is usually by just constructing a circle. So what I mean is this, and you guys did a really great job betting this out. In fact, it didn't take you guys very long to figure this part out. If I have A and A prime, and I say I want the center rotation to be, to say C for the, just for the ease of it, I have to show that these two distances are the same. And the easiest way to show that is to introduce the idea of a circle. Because we know by rule that all the points from the center of the circle out to the circumference are the same distance. And in this case, since the center is C, these both serve as radii, so they're actually automatically going to be the same distance. So since these guys are radii, they're automatically the same. So a way to kind of short what we wrote over here is, in other words, construct a circle with center of rotation as the center. So that's condition one, but of course, just having the center there is not enough. We also have to ensure that the angle of rotation, whatever it happened to be named, I'm going to call it angle x just for ease for us today. We have to make sure that angle x is the angle that's formed between those 3 points. So we have to show that the angle, wow, what am I trying to spell there? Bam. Okay, we have to show that the angle formed between the image, the pre-image, and the center is the same as the angle of rotation. So so the angle formed between, whoa, I hate that thing. Get out of here. The angle formed between, excuse me, the pre-image, the center of rotation, and the image is the same as the angle of rotation. Okay, so what do I mean? I'm going to go back to this, I'm going to go back to an example. So if I'm claiming that I have this rotation in which I have a 40-degree angle rotated about point R, R's a bad choice. I'm going to use R for reflection, Mr. Collins. Rotated about point Y of the point B goes to B prime. Then what I have to show is actually two things. I have to show that the distance between Y and B, the distance between Y and B is actually the same as the distance between Y and B prime. And then I also have to show that the angle formed between B, Y, and B prime is going to be 40 degrees. So just as a quick sketch, let's say this is going to be B. Let's say this guy down here is B prime. And then well, that's a little off actually. I can't live with that. This guy right here is going to be B prime. And then I have my center of rotation right here as Y. I have to show two things. Again, the first thing I have to show is that these distances are the same. I can accomplish that by actually drawing a circle or indicating that these both form on a circle or simply showing these distances to be the same. And the second thing I must show is this angle right here is 40 degrees. If those two things are true, then this reflection, or this rotation, excuse me, actually happened, and that's the confirmation you have. So if those two things are not, oh, okay, Minnesota Lynx. Go Minnesota Lynx. Yay, WNBA. Okay, so if I can show those two things are actually the same, we are good to go. Okay, so that's the notes. Now, again, if you kind of look at the video time, that's been about 20 minutes, but these notes are extremely extensive. They cover a lot. They tell you everything you need to know about how you can tell something is going to be a rotation, what the terminology is, what the rules are. You have a couple examples actually intermixed with the notes, and I think we did that in a much better time frame than we could have done in class. And the advantages now you can watch this and rewatch this and make sure your notes are muy bueno. Okay, so here's what your task is now, and here's how you're going to kind of finish this up. Of course, take time if you want to clean up what you need to clean up. But then I now need you guys to construct this summary. Now, again, I'm going to remind you of the summary process. And it's a serious one, okay? So if you do this right, you will improve your comprehension. You have no choice. Okay, so the steps to summary is this. First, you have to go back through your notes, and you have to reread them, of course. And I want you to highlight, underline, whatever, 3 words or phrases that you feel are essential to answering the essential question. Okay. The next step is then to craft a summary. That answers the essential question. And uses those words or phrases you used or identified. Okay, so here's how I want you to keep accountable for this. So I want you to go ahead and do that. Go through your notes, do the words or phrases, go ahead and do the summary, write your summary into your notes, and then I want you to go to Edmodo. Okay. Go ahead and log into our page. If for some reason you don't remember your login information, create a new account. The code for our class is EXPLDE. Okay, in other words, it's explode without the O. Okay, so go ahead and log into Edmodo. Open up a thread. Give that thread, targeted to geometry honors, and I want you guys to type in your summary into edmodo.com on the page. Okay, so I want everyone to go, after they write the summary, okay, then I want you to post your summary on Edmodo. Okay? Now, I want you to post it with a very specific title. Like the first thing I want you to do, when you actually go into the Edmodo page, right? When you're typing in, I want you to title it first as Reflection Summary. And then skip a line and then actually type your reflection down here before you actually post it, okay? So that's what I want you guys to do. I want you to make sure that you do this. If it's not during class, because it's likely maybe not everyone got to the end of the video here by class, then do it before you see me next, okay? So make sure you guys are doing that. This will allow you guys to do a couple things, because one thing that's important in this process is getting your ideas out and making sure that you can get your ideas critiqued. So if you don't post your summary, you don't get critiqued. Get critiqued, or at least get to see other people's responses and craft a better one on your own. So once you get able to see a lot of people's responses, go back to your notes, tweak it, get some feedback, add to it, boom, there you go. You got the information needed. Long video, I'll try to make it more concise in the future. Now do please take a note. I'm going to do a part 2 of this video right now, and it'll be posted also with this. That covers the noting of that shortcut grid, like that big table that has the 5 parts how you can tell translation, rotation, or reflection,
and we have reflections filled out. So I'm going to do the other part right now. You guys have a good day.